Hello pre-calculus students, and welcome to a video on piecewise defined linear functions. Now when it says linear functions, I mean lines. These are all going to be lines. When we get to lesson 4-3a, we're going to be looking at curves. Anything that we know the parent function will be a potential curve that we're going to graph. Alright, so for this we have the goal here, what is a piecewise defined function, is it's a function that has two different rules. In this case, they're all going to be lines for different parts of the domain. All right, so let's look at the first of those piecewise defined functions and see what we have. All right, so what we need to understand first is what we're seeing here. It's a function that has this rule for this part of the domain, and then it has this rule for this part of the domain. In other words, we're going to graph the line y equals negative x minus 2, but only when x is less than or equal to 2. And then we're going to graph y equals x minus 4, but only where x is greater than negative 2. All right, so we're going to do this one at a time. And the way I do this, I recommend, first of all, you have a pencil, not a pen, because we might do some erasing. And also, I'm going to recommend that you have some kind of a highlighter so we can actually highlight what's important here. All right, so let's first graph the line h of x equals negative x minus 2. Just graph that line like you normally would. All right, it has a y-intercept of negative 2. And it has a slope of negative 1, so it goes down 1 over when it's negative, so it's that way. And then we're going to connect those points to make the line, just like we normally would graph the line. All right. Now, this has an end point because it includes the point where x equals negative 2. And basically what I'm looking at here is everything where x is less than or equal. So I only want this part of the line. I don't want this stuff because that's not following the domain that I'm told to graph this line for. Okay, so when x is less than or equal to 2, I'm going to put a closed circle there. And I'm actually just going to get my highlighter and darken that point at negative 2 and then continue it, and that's what the graph will look like. Now, whenever you graph a piecewise function, and a piece has an end point or an end hole sometimes, you need to let me know what that is. So in this case, it's negative 2, and it looks like it's negative 2, 0, but let's just make sure by finding h of negative 2, because sometimes you can't tell as well as we can tell here. So you have the opposite of negative 2, minus 2, which is in fact 0. So this is 0. Okay, so far so good. Now we're ready to graph the second piece of the piecewise function. So now we're going to graph, now if you want, by the way, you can erase the rest of this line. It's not important. If it makes it more confusing for you, you can erase it. You don't really need to. You don't need to as long as you have it highlighted, okay? I can tell by the highlighter. If you don't have it highlighted, you just have the pencil, you have to erase it. All right, x minus 4. So now we're graphing the line h of x equals x minus 4. Okay. We're just going to graph that line like we normally do. A y-intercept of negative 4, a slope of 1, so it goes up 1 over 1, up 1 over 1, connect it, and again, I'm not even thinking about the fact that I'm graphing piecewise, I'm just graphing the line. And there we go. Now this line, I only want where x is greater than negative 2. So here's my negative 2. And here is the point where the negative 2 is. I'm going to erase it and put a nice open circle there so it's very clear. So an open circle there, and I'm going to highlight everything greater than that open circle. Goes on forever. Now, like I said, you need to always graph the end points or end holes. This is an example of an end hole. Let's find where the hole is. So there's a hole, because we're not including the negative 2. There's a hole at h of negative 2. In this branch. Don't look at this one because we're focusing on this one now. So that is negative 2 minus 4, negative 6. It's right where it looks like it should be. It's at negative 2, negative 6. Let's write that down. And we're done with the first piecewise graph. Okay? Let's look at number 2. Here's another piecewise defined linear. This is a linear piecewise because all three of these pieces are lines. Yes, you heard me right. This time there's 3 linear pieces, and we're just going to graph them all separately. All right, now first of all, this first one is just h of x equals 3. And we know that h of x equals 3 is a horizontal line that's up at y equals 3. So I'm just going to graph that horizontal line like I normally would. And now I'm going to look at the domain restriction, and it says I only want this when x is less than -4, so I'm only going to count the stuff over there. I don't want anything greater than -4, and I don't want to include -4. So I'm going to erase that, put a nice clear hole there at -4, and highlight everything less than -4. And I'm not going to bother erasing the rest of that. I'm just going to keep what's graphed here. Okay, so there's the clear hole and the rest. All right, let's look at the next piece. So the next piece is h of x is -2x minus 2. I'm going to graph this and come back to you. So you guys graph it too. Okay, so I graphed the line that has a y-intercept of -2 and a slope that goes down 2 over 1. This is a negative slope. And so now I want to look at the domain restriction for that line. So I want everything from -4 to +1. So -4 is right here. So I don't know exactly where that point is now. I'm not quite as sure as I was in the other case, but it looks like it's somewhere here. And I'm going to draw that endpoint at -4, so it's going to just continue a little bit too far. It's an endpoint, so like that. And I go all the way to 1. So here's x equals 1. So I want the point here, but this one is an open circle. So I'm going to erase the point that I actually graphed as part of how I made this graph and keep the open circle. Now what I want is I want from here to here. Now sometimes, and this is almost there, sometimes it's really going to be hard to know whether or not these two graphs touch. So you're going to have to use graph paper, and you're going to have to be as precise as you can and use rulers for these to really be able to tell. But also we'll be able to tell because we're going to find this value, and we're going to know whether or not, in this case it's pretty far. It looks like it's -4, +5, but let's just make sure. Let's find h of -4 and see if we graph this accurately. So h of -4 is -2 times -4 minus 2, and that's 8 minus 2, that's 6. It looks like I'm a little bit off, but that's okay. But as long as I say what the point is, this is -4, 6. Okay, now let's see what h of 1 is. So we want to see what the hole is on the other side. Remember, this is a hole. So h of 1, and it looks like, let's see if I'm more accurate this time. I don't know. It looks like it's somewhere between -3 and -4. h of 1 is -2 times 1 minus 2. That's -4. So this is, in fact, 1, -4. Okay, so let's label that point 1. I'm just going to erase this to get it out of my way, so I can write the point 1, -4. There's my end hole. All right, we got one more piece of this graph, and that's where x is greater than or equal to 1. Let's first graph the line. So it has a y-intercept of 1 right here. It has a slope of +2, so it goes up 2 over 1. And it's going to be something like this. I'm going to get a third point so I can try to be a little bit more accurate than I was last time. Okay. Now I only want this when x is greater than or equal to 1. So here's the 1. I want this part, and I want everything to the right of that, which is also pretty much going up. And there's the end point. You can clearly see on my graph, there's holes here and here, and there's points here and here. Let's label this last end point by finding h of 1. That's the end point. So h of 1 is a point. This, by the way, h of 1 on this one was a hole, right? Because it says it's not including 1, so that's an open circle. And this one was also a hole. So here, we didn't actually find that, but h of -4 equals 3, and that's a hole. All right, so let's do this one, h of 1 from this function, which is 2 times 1 minus 1, which is 1. So there should be a point 1, 1. That looks pretty good. 1, 1. Okay, and that's the end of the second example. Let's look at one more. Actually, let's make this the end of part 1, and we'll look at the other one as a sort of a different concept, slightly different concept. I hope you found this video helpful.